Hello, my name is Navi Varshni. In this project, I have built an event-driven backend system to track user activities such as login, logout, and page views. The system follows an event-driven architecture where services communicate asynchronously using a message queue. For this implementation, I used a Fast API for the producer API, RabbitMQ as the message broker, MySQL for a data storage, Docker and Docker Compose for containerization. The main problem I solved is eliminating tight coupling between services instead of directly writing to the database. Events are published to a queue and processed asynchronously. A real world use case of this system is tracking user behavior in applications like e commerce, platforms, analytics systems, or audit logging systems. This system consists of two main services: product services that accepts API requests, validates input, publishes events to RabbitMQ, and a consumer service listens to the queue, processes events, stores them in MySQL. RabbitMQ acts as a decoupling layer between the services. This approach improves scalability, fault tolerance, asynchronous processing. The producer does not wait for the consumer, making the system highly responsive. Yeah, this is my folder structure. Here is the project structure, and this is the project product services, and this is the consumer services, and this is db init.sql and docker compose.yml, and this is my readme.md, and these are the tests. And and now here Here we define the API endpoint. Post API v1 events track. It validates input using Pydantic, then publishes the event to RabbitMQ. This function connects to RabbitMQ and publishes message with the persistence enabled. And now consumer.py. This service connects to RabbitMQ with the retrieve logic, consumes messages, passes a JSON, inserts into MySQL database. It also acknowledges messages after successful processing. And now init.sql. This file creates the user activities table with the user ID, event type, timestamp, metadata. And docker compose.yml, this file orchestrates RabbitMQ, MySQL, producer service, consumer service. It also includes health checks to ensure services start correctly. And already I have built the docker. As you can see, uh, consumer started waiting for messages and connected to RabbitQ successfully. I have started all the services using Docker Compose. Here you can see all the services have built. And now we have to send an API request. Yeah, here you can see event accepted. The API returns do not to accepted, which means the event is a successfully queued. And now Docker compose logs consumer service. Yeah, here you can see event stored successfully. Events received and events stored successfully. This proves asynchronous processing. And now again open git bash. Yeah, here you can see. And now use user activity db. No. Little mistake. Yeah, here you can see, we can see the event stored in MySQL confirming end-to-end flow. Now, the most challenging part of this project was handling service startup dependencies. Initially, the consumer tried to connect to RabbitMQ before it was ready, causing connection failures. To solve this, I implemented a retrieve mechanism in the consumer which continuously attempts to connect with the RabbitMQ becomes available. Another challenge was ensuring proper message acknowledgement to avoid message loss or a duplication. Some limitations of the current implementation are no retrieve mechanism for failed database operations, no dead letter queue for failed messages, no authentication for the API, and basic logging only. Future improvements could include adding a dead letter queue, implementing retrieves with the back of, adding monitoring and metrics, securing the API, the authentication, and scaling consumers horizontally. This project demonstrates a scalable event-driven architecture using RabbitMQ, FastAPI, and MySQL. It ensures decoupling, asynchronous processing, and better system resilience. Thank you.